Chapter 1 Introduction. Data Communication. Networks. Protocols and Standards. Standard Organizations. Data communication is the exchange of data, in the form of 0s and 1s, between two devices via some form of communication medium. Data communication is considered local if the communicating devices are in the same building. It is considered remote if the devices are farther apart, at a distance. The effectiveness of a data communication system depends on three fundamental characteristics. 1. Delivery. The system must deliver data to the correct destination. Data must be received by the intended device or user. 2. Accuracy. The system must deliver data accurately. Data that been altered in transmission and left uncorrected are unusable. Timeliness. The system must deliver data in a timely manner. Data delivered late are useless. A data communication system is made up of 5 components. 1. Message, 2. Sender, 3. Receiver, 4. Medium, 5. Protocol. Message. The message is the information to be communicated. It consists of text, numbers, pictures, sound, or video, or any combination of these. 2. Sender. The sender is the device that sends the data message. It can be a computer, workstation, telephone handset, video camera, and so on. 3. Receiver. The receiver is the device that receives the message. It can be a computer, workstation, telephone handset, video camera, and so on. 4. Medium. The transmission medium is the physical path by which a message travels from sender to receiver. It can consist of twisted pair wire, coaxial cable, fiber optic cable, laser or video waves. 5. Protocol. It is a set of rules that govern, manage, data communication. It represents an agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating. 2. Networks. A network is a set of devices, nodes, connected by media links. A node can be a computer, printer or any other device capable of sending or receiving data generated by other nodes on the network. The links connecting the devices are often called communication channels. Distributed processing. Network criteria. Reliability. Security. Applications. 1. Distributed processing. Networks use distributed processing, in which a task is divided among multiple computers. Instead of a single large machine being responsible for all aspects of a process, each separate computer handles a subset. Advantages of distributed processing. Security. Encapsulation. Distributed database. Faster problem solving. Security through redundancy. Collaborative processing. Security. Encapsulation. A system designer can limit the kinds of interactions that a given user can have with the entire system. For example, a bank can allow users access to their own accounts through an automated teller machine, ATM, without allowing them access to the bank's entire database. Distributed databases. No one system needs to provide storage capacity for the entire database. Faster problem solving. Multiple computers working on parts of a problem concurrently often can solve the problem faster than a single machine working alone. Security through redundancy. Multiple computers running the same program at the same time can provide security through redundancy. Collaborative processing. Both multiple computers and multiple users may interact on a task. Network criteria. To be considered effective and efficient, a network must meet a number of criteria. Performance. Performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between an inquiry and a response. The performance of a network depends on a number of factors. Number of users. Type of transmission medium. Hardware, software. Number of users. Having a large number of concurrent users can slow response time in a network not designed to coordinate heavy traffic loads. Type of transmission medium. The medium defines the speed at which data can travel through a connection, the data rate. Today's networks are moving to faster and faster transmission media, such as fiber optic cabling. Hardware. The types of hardware included in a network affect both the speed and capacity of transmission. Software. The software to process data at the sender, receiver, and intermediate nodes also affects network performance. 3. Reliability. Network reliability is measured by frequency of failure, recovery time of a network after a failure, and the network's robustness in a catastrophe, disaster. Frequency of failure. All networks fail occasionally. A network that fails often, regularly, however, is of little value to a user. Recovery time of a network after a failure. How long does it take to restore service? Security. Network security issues include protecting data from unauthorized access and viruses. Unauthorized access. For a network to be useful, sensitive data must be protected from unauthorized access. protection can be accomplished at a number of levels. At the lowest level are user identification codes and passwords. At a higher level are encryption techniques. Viruses. A virus is an illicitly introduced code that damages the system. A good network is protected from viruses by hardware and software designed specifically for that purpose. 5. Applications, marketing and sales. Financial services, manufacturing, electronic messaging, directory services, information services, electronic data interchange, ED, teleconferencing, cellular telephone, cable television. 3. Protocols and standards. Protocols. A protocol is a set of rules that govern, manage, data communication. A protocol defines what is communicated, how it is communicated, and when it is communicated. The key elements of protocol are syntax, semantics, and timing. Syntax. It refers to the structure or format of the data, meaning the order in which they are presented. Semantics. It refers to the meaning of each section of bits. Timing. It refers what data should be sent and how fast they can be sent. Standards. Data communication standards fall into two categories, de facto and de jure. De jure standards, standards that have not been adopted as standards. De facto standards, established originally by manufacturers seeking to define the functionality of a new product or technology. De facto standards can be further subdivided into two classes. 1. Proprietary, originally invented by a commercial organization, it also called closed standards. 2. Non-proprietary, originally developed by groups or committees that have passed them into the public domain, it also called open standards.